Hi, good day, everyone. I still remain your humble self, and I saw Emmanuel. I'm actually an IMG. I've tutored a lot of students from the Caribbean. I finished from the Caribbean Medical School, and my intention is to be like a mentor and serve like a guide to medical students and also to doctors that are writing this exam, help them with test taking skills and also help them be able to understand the content of this exam. So today I will just be talking about hypothesis testing, what it entails, different kinds of hypothesis testing from the t-test, different kinds of t-test, the chi-square and the ANOVA. Because of time limitation, I have to be a little bit faster, trying to break down the concept of hypothesis testing and also trying to help you go through a question STEM when you see one in an exam on the Usmle exam. Let's just look at these. While a researcher studies whether a new antihypertensive medication lowers systolic blood pressure more effectively than placebo. One group of patients received the new drug and the separate group received the placebo. After 8 weeks, the mean systolic blood pressure of both groups is measured and compared. Which of the following is the most accurate statistical test to analyze the data? So we have the PET test, we have the unpaired t-test, we have the chi-square test, the one-way ANOVA, and the Pearson correlation coefficient. So if you look at this is a study of a drug that lowers systolic blood pressure. One of them, or one group are people that receive the new drug. The other group is groups that receive the placebo. So they're compared between two groups. The mean systolic blood pressure of both groups is measured and compared. So which of the following do you think could best? So let's go to the explanation for this. So the correct answer is independent or PET test. And the reason why it's actually the correct one is this. The outcome variable is continuous in the same that the systolic blood pressure is a continuous variable, and there are two groups. That's why the t-test actually fits into the best picture, and the groups are independent, different patients in each group. Therefore, the correct test is an independent or an unpaired t-test, which compare the means of two independent groups. So we'll have to talk about the reason, because one of the things for USMLE exam is test taking skills and be able to rule out the other option. But when you see it in another form or in another different dimension, you can be able to recognize it. So why do you think the other one's wrong? So for the PET test used for the same subject before and after treatment, if you look at this question, these are two different groups being compared between the placebo, or rather the placebo groups versus the treatment groups. So it's not before and after treatment. That's why the PAT test is wrong. The chi-square is mainly for categorical data. This one is a continuous data, not for categorical data. And also the chi-square is also used for means. One way ANOVA is for comparing three or more group of people compared to that of um unpaired t-test, which is more two groups. Pearson correlation measures relationship between two continuous variables, not group comparison. So let's look at hypothesis testing. It helps us decide whether our observed difference is real or just due to chance. Well, let's start with no hypothesis that shows no difference. Alternative hypothesis shows that there is a different example. When you're comparing the mean systolic blood pressure between patient on drug A versus placebo, there are different types you can actually use. You have the independent t-test and the pair t-test. So for that particular patient, it's an independent. So this one tests different groups, just like the patient actually entails. And we have the PET test, which is same group before, same group. So look at the difference. For independent, is different groups. For PET test, is the same group before treatment and after treatment. Same group, not different groups. Then for chi-square test, it's just used to comparing proportion. Data is always categorical. Example is when you're comparing smoking status between lung cancer patient and controls. So if it has to do with something like percentages, the rate proportion, you think of chi-square, but it has to do with mean, think of a t-test. ANOVA is also can be used for comparing means, but the keyword is it has to be three or more group of people. Three or more group of people. If it's only two, it's not ANOVA. Three or more group of people. Like a typical example is when you're comparing mean cholesterol levels in patient on drug A, drug B, and placebo. Key concept. ANOVA tells us if at least one group is different, but not which one. Post hoc tests do that. So Wrap-up summary. The t-test, remember, same group is the paired t-test, different groups is independent t-test. So t-test is measures two groups who have the paired and the unpaired t-test, right? Chi-square is proportional and just categorical data, not for continuous data. ANOVA is means, but it has to do with more than three groups. So if you can identify the type of data number of groups, the correct test now become very obvious. So these are the keywords. Whenever you're talking about hypothesis testing, pay attention to whether it's the means, whether they're talking about categorical data versus continuous data, whether they're talking about the same group being treated before and after, um, same group being given the same treatment and also after treatment, whether it's a different group being given treatment, like one being a control, one being a control and one being the treatment group. So, and also if you can also know whether it's three or more, that will help you know the type of hypothesis testing that they're talking about. So a teaching pair means plus two groups t-test, proportion chi-square means plus three groups ANOVA. So this is the end of my presentation. I hope you guys were able to grab something about hypothesis testing, because this is a very important concept being tested for the USMLE step one exam. It comes out in mostly all the exam from step one, step two, and step three. Step three biostat is really high yield, so I would always suggest and advise a better understanding of this high yield concept to help you to navigate through the biostat section of the USMLE exams. Thank you so much. I still remember your humble self. Dr.